Okay, so the next thing that we have here is the coordinates of a point in space, which is basically more of something like a definition. So as you can see over here, we have in a basically in a 3D coordinate system, we have all of these 8 octants over here, 4 over here and 4 down here, and these octants are, of course, then they help us to represent the position of a point in any point in space, wherever that might be. Now if I take basically the first octant over here, which is this x, the x-axis would be something like this, for example. So the x-axis, for example, would be this axis over here, this would be the z-axis, and this would be the y-axis. I would have 3 basically mutually perpendicular axes, and they would look something like this. They would look something like this. You can of course do it in any way that you want, depending on the point where you look at the axis. They will look differently, but of course, and it's going to be something like this. And then this would be the z-axis, this would be the y-axis, and this would be the x-axis, and this would be the center of the coordinate system. So now imagine that I have the first octant over here, drawn over here, and then for now we can just forget about this thing. Now if I have my coordinate system over here, now since we have chosen a fixed coordinate system in space, meaning that you can imagine that the whole coordinate system, you can consider that as a unit, as a unit system, basically. And in this system, basically, you have the coordinate axes, and you have the coordinate planes, and you have the origin. Then related to any point in space, there are basically 3 coordinates: the x coordinate, the y coordinate, and the z coordinate, and that would basically describe the 3 numbers taken together would describe the position of any point in space. Okay, so what that means is that, what that means is that if you have any point in this coordinate system, then based on the coordinate system, you can associate 3 numbers basically in this order to that point, and then therefore you can basically describe the position of that point in space using these 3 numbers called the triplet. Basically called the triplet. And conversely, what you can do is that if you are given some triplet xy, y1, and z1, if you have such a triplet over here, we can, using the same coordinate system, we will be able to locate that point in that coordinate system. So these are basically 2 different things. Either you have some point over here, and using the coordinate system, you will be able to assign 3 numbers over here called the triplet to that point, and thereby basically explain or basically define define the location of that point in space. And conversely, what the other thing that you can do is that any triplet that you're given, you will be able to locate that point in that coordinate system. And that's basically the two different things that basically this coordinate system can do for you, which you can see as converse processes or reverse processes basically. So now imagine that you are given a point in space, for example, somewhere over here. You have, for example, this point over here, and you want to find the position of this point in the coordinate system. So you drop a perpendicular on the XY plane. So there is a plane over here associated with these two axes as we discussed before. So you need to drop a perpendicular to the XY plane. So this line is now perpendicular to the horizontal plane that is associated with these two axes, which is called the XY plane. And this is actually the XY plane is actually nothing but this green plane that you can see over here. So I drop a perpendicular to that plane, and I call the foot of this perpendicular, I call it M, for example. Then from this point M, you draw a perpendicular ML to the x-axis, and that would look like something that will look like this, for example, something like this. And I call this point L, for example. And this L is now along the x-axis basically. Now you can imagine that, for example, OL is equal to x, the x coordinate, or you can say let OL is equal to x, meaning that this distance over here, I call it the x coordinate of my triplet. Now LM, you can call it y, this distance over here. This distance over here, you can call it y. So LM is equal to y, and MP. So this point is basically called P, of course. MP, I call this point as, this is M. So MP, I call it Z. So this is the x coordinate, this is the y coordinate, and this is the z coordinate of this point. Of this point P in space. So then you will have a triplet like x, y, z, which describes the location of this point in space. And of course, you can see that since the octant that we chose for this particular activity, the octant is basically the XOYZ octant, which is of course the first octant. And you know that in the first octant, x is positive, y is positive, and z is also positive. And of course, if you were in any other octant, so the signs might change accordingly. So for example, if you go to the octant behind this octant, the second octant, then for example, your x would be negative. So but of course we are going to have a table and we are going to write down the signs of all of these x's and y's and z's in different octants. So then, based on the process that you saw over here, so you can say that thus to each p in space, to each P in space, there corresponds an ordered triplet. There corresponds an ordered triplet, XYZ of real numbers. So that's a triplet of real numbers. So that's the first part. And then conversely, if you have a triplet, we said that you can locate that point in space. So conversely, given any triplets, for example, given any triplet XYZ, we would first find you can first find the OL distance related to this triplet, the point L on the x-axis corresponding to x. First you can find that distance, then locate the point M, in the xy plane, such that, so step number one, of course I'm not very much in favor of steps or anything, but as long as we are going to talk about it, we are going to have to talk in some order. So I just call them steps number one. Step number one, basically you can say that you can fix the point L, you can fix L along the x-axis corresponding to x, which is basically what we did, of course, in the previous process as well. And then locate the point M in the xy plane. Step number two, locate the point M in the xy plane, such that x comma y, and you see that this is the y coordinate of the point, such that x comma y are the coordinates of the point M in the xy plane, are the coordinates of the point M, of the point M, not point P but point M in the xy plane, and of course you know that LM is perpendicular to the x-axis, or LM is perpendicular to the x-axis, or basically parallel to the y-axis. So you already know that. Now that you have reached point M, we draw a perpendicular MP to the xy plane. So then step number three, locate, not locate, but we draw a perpendicular MP to the xy plane, and then locate on it, on that perpendicular, meaning that once you reach this point M, you draw from that point you draw a perpendicular to the xy plane, which will of course be this line over here, and this line is perpendicular to the xy plane. and then locate on it the point P corresponding to Z. The point P corresponding to P, corresponding to Z, meaning the height of that point. So that's basically that's basically how you get to point P over here. And then the point P basically so obtained is going to have the coordinates X, Y, and Z. Thus there is a one-to-one correspondence between the points in space and ordered triplet XYZ of real numbers. So this sentence is important. So then you can say that, so basically in the first step or in the first process, we had a point over here, and through the process that we went through, we assigned 3 numbers to that point, essentially a triplet of real numbers, and that was the location of that point in space. And that conversely what we did, we had a triplet of numbers, basically X, Y, Z, and then using this process, we located that point in space. Thus, so considering these two basically converse processes, you can say thus there is a one-to-one correspondence. Thus there is a one-to-one correspondence between the points in space, between points in space and ordered triplets and ordered triplets XYZ of real numbers. And what this means, that one-to-one correspondence between points in space and ordered triplets XYZ of real numbers, meaning that any point that you have in space corresponds to one and only one triplet of real numbers, and any triplet of real numbers that you have will correspond to one and only one point in space, and these will be of course unique always, meaning that it's not possible that you can have that you have a triplet over here and then you can assign it to 2 points in space, that the point is always going to be unique. And also it's not possible that you can have a point in space and then you can assign that point to 2 triplets of real numbers. That triplet of real numbers will also always be unique. So that is basically one thing. Now there is an alternative way of doing the same thing, which we will talk about as well. Okay, so now the next thing, that basically the same thing that we did in the previous 2 processes, which were converse processes, you can do it in a different way as well. So suppose that you have this point, suppose that you have this point P in 3-dimensional space. So suppose that, for example, the point P is, for example, some point over here. So what you want to do is basically through this point P, you want to draw a line. Basically, you want to actually, you know that basically you have this plane over here, which is the XZ plane, the plane that goes through basically OX and OZ. That is the OZ plane, and then you have a plane over here at the back, which is the YZ plane, and then you have the XY plane, which is the horizontal plane over here. So you have basically 3 planes over here, one at the bottom, one at the back, and one over here at the side. So through this point over here, you want to basically draw 3 planes in such a way that the 3 planes are parallel to basically the XZ plane, parallel to the YZ plane, and also parallel to the YZ plane. So if you want to do that, so basically you need to drop a perpendicular, for example, to the XY plane, and then you can basically draw a line parallel to the y-axis, which would be basically this thing over here, and then that would be perpendicular to the x-axis, and then from here you can basically, from this point P, suppose that this is your point P, so then I can draw, for example, this line over here. Of course, this is just for the sake of demonstration, and if I basically connect these lines together, I will get some plane that is basically parallel to the YZ plane. Now I need a plane over here which is parallel to the XZ plane, and in order to do that, I can basically, from here I can drop a perpendicular to the Z axis, which would be something like this, and from here drop a line which is basically parallel to the y-axis, which would be something like this, and then from here a line which is parallel to the x-axis, which would be something like this, and then from here again I need a line that is parallel to the x-axis, which would be something like this, and then these two must actually meet, but they don't, and that must be because I have done my lines not exactly properly. But that's not a problem. As I said, this is just for the sake of demonstration. Now over here, what I have is basically these planes over here. So this is the point P, and now this distance is going to be, this distance over here is going to be y. Let me do it with another color so you can see it properly. This distance over here is going to be y. This distance over here is going to be x. This distance over here is going to be x, and this distance over here is going to be z, and that is basically these are the coordinates of your point P. So we draw 3 planes parallel to the coordinate planes, meeting the x-axis, y-axis, and z-axis in the points A, B, and C. So these are the points A, and this is the point B, for example. This is the point B, and this would be the point C. And let OA be equal to x, for example, and let OB be equal to y, and let OC is equal to z, and then the point P will have the coordinates x, y, z, and we write P as the coordinate having the coordinates x, y, and z. And that's basically another way of doing the same thing, meaning finding the coordinates of this point P in 3-dimensional space. Of course, this seems to be a little bit, I mean, going through all of these steps seems to be a little bit going over the top. Okay, so so basically that way you could find the coordinates of the point P, the XYZ, and then we have basically the converse process is also, you can do the converse process here as well. Given XYZ, so let's say that you have P with coordinates XYZ. Given XYZ, we locate the 3 points A, B, C on the 3 coordinate axes. So you can locate the A, B, and C. A corresponding to X, B corresponding to Y, and basically C corresponding to Z. And then using these 3 points, then you can reconstruct this rectangle over here. And then this vertex of the rectangle will be basically your point, the location of the point P. Basically, that's the whole process really. We locate the 3 points A, B, and C on the 3 coordinate axes. Through the points A, B, and C, we draw planes parallel to the XZ, YZ plane, ZX plane, and XY plane respectively. And the point of the intersection of these 3 planes is going to be the point P. So this is of course important, meaning that you can use this technique in solving problems basically. So again, I was going to say something. I don't really remember whether I said it or not, or I was actually talking about it, and the fire department again paid us a visit, and so I had to stop. So this whole process that I'm talking about right here, that for example locate this point across this axis and locate that point across that axis and do this and do that, and this has to be, for example, parallel to this or perpendicular to that. This seems to be a little bit over the top, meaning that you might think that, okay, so I don't really need to know all of these details about the simple coordinate system. But for example, when you know that basically the process that you need to go through in order to locate this point P is that, for example, you can locate the point A across or along the line OX, and then locate the point, for example, C along the line OZ, and locate the point P along the line Y. And then through this point A, you need to draw a plane parallel to the YZ plane. Through this point B, you need to draw a plane parallel to the XZ plane. And then through this point A again, you need to draw another plane parallel to the YZ plane. And I think I said that already, but through the point C, you need to draw a plane parallel to the XY plane. And then the point of intersection of these planes, is going to be basically your point P. So now you can use this idea later in analytical geometry in order to find the position or the location of a point in 3-dimensional space. Meaning that, for example, if you know about the concept of the point of the intersection of 3 planes in this manner, then you will be able to use it in any way in order to do anything with it in analytical geometry, because then when it comes to analytical geometry, all of these concepts will be represented in terms of algebraic equations. And then using algebraic equations, of course, you don't need to draw diagrams all the time. You can use a couple of equations to find the location of something, to find some distance in 3D space and so on and so forth. So that's basically where the why all of these concepts are important to understand. So basically, normally, for example, you wouldn't pay attention to the fact that this point P, and I did not, I myself did not pay attention to the fact that, for example, this point P is the point of intersection of this plane and this plane and this plane over here. So these are the important details that you should not miss. So now if I call these, for example, these points F and, for example, E, and this point D, for example, this point D, then the point of the intersection of these three planes, basically ADPF, which is this plane over here, and the point of intersection of, so the point of intersection of the point of intersection of the planes ADPF and BDPE, which is this plane over here, BDPE, and CEPF and CEPF, which is basically this plane up here, is the point P, is the point P, corresponding to the ordered pair corresponding to the ordered, not pair but triplet, not pair but triplet X, Y, Z. And one more thing that basically again is important is that again we observe that X, Y, if basically P with coordinates X, Y, and Z is any point in space, then X, Y, and Z, are the perpendicular distances of the point P from the planes basically the perpendicular distances of the point P from the planes. So you see that over here your Y is the perpendicular distance of the point P from the plane, from the XZ plane, so your X coordinate, your X would be basically the X coordinate of the point. The X coordinate of the point would be the perpendicular distance of P from the the perpendicular distance of P from the YZ plane, the y coordinate of the point is the perpendicular distance of P from the XZ plane. So you see that over here you have X, and here X is absent. Over here you have Y, over here Y is absent, and you have only basically X, Y, and Z. So that way you can remember this, meaning that X is the perpendicular distance of the point P from the YZ plane, Y is the perpendicular distance of the point P from the XZ plane, and so then logically then Z is the perpendicular distance of the point P from the XY plane. And then again, you will of course be able to, and you actually do need these basically these concepts in analytical geometry in order to be able to solve problems. And then what's more is that you are going to need analytical geometry in order to understand the rest of your mathematics. So basically the logical chain between all of these things that we are doing here is that these concepts that we are doing here, these concepts you're going to need them in order to understand three-dimensional analytical geometry. And this thing over here, three-dimensional analytical geometry, you're going to need this. You're going to need to know this in order to understand the rest of mathematics, because without that, of course, you will not be able to understand the rest of mathematics. And then, assuming that you have understood the whole of mathematics, then you're going to need the whole of mathematics. You're going to need the whole of mathematics in order to understand physics. And or understand, for example, I don't know, chemistry. Understand chemistry or any other branch of science for that matter, really. So this is basically the logical chain between all of this. Any concept that we talk about here, all the details of that concepts you need to know in order to understand the rest of your mathematics. Then supposing that you have understood well the rest of mathematics, then that means that you can assume that then you have understood the whole of mathematics. And the whole of mathematics you are going to need to know in order to understand physics or chemistry and other branches of science, and that becomes your basically education. So, and without an education, there is actually no way to be in any way or by any definition successful in the world today, because the world is today purely based on education. But of course, well, if you have seen that, for example, the people who have understood basically their concepts at school, then they of course they logically end up working in for example in Apple or in Google or in other basically top companies in the world. And those who have not understood their concepts well, they end up having trouble getting any job at all, really. That's basically what's happening today. So then basically these are of course really important. And of course the emphasis of all that we are doing here is not to basically to end up, for example, well, of course, getting a job at Apple or Google or all of those top good places are of course completely okay. I mean, there is nothing wrong with that. But the emphasis of all that we are doing over here is to understand all of these concepts, so that you are a really educated person, so that you can actually use this education in a meaningful way, so that basically you can, I don't know, do something on your own, probably with what you learn on your own over here. And but of course, doing something really useful and meaningful in the world, meaningful to yourself with what you learn over here. That's basically why we take all the time to basically understand all of these concepts. And of course here, well, I mean, I for one I'm not really in need of any certificates or certificates from any university or anything like that, but well, of course, in today's world, you do need to understand all of these concepts. There is no way around that. So so that's basically that. So hopefully you have understood all of these concepts. The next thing that we have here is the coordinates of the origin that we had here. The origin that we had here, we called it O, and the coordinates of this point over here with respect to this whole coordinate system is 0, 0, 0. That is these are the coordinates of the origin. And of course, naturally, any point on the x-axis, this is also important. You can use all of these facts in many different ways. So any point, if you find any point on the x-axis, of course you can see that basically on the x-axis your y-coordinate is going to be 0, your z-coordinate is going to be 0. Your point is just along the x-axis. So that means that any point on the x-axis will have coordinates x, 0, 0. Any point on the y-axis will have coordinates 0, y, 0, and any point on the z-axis will have coordinates 0, 0, z. And then when it comes to the planes, you can say that, for example, you can say that any point in the YZ plane, you can say that any point on the YZ plane will have coordinates. So if you are on the YZ plane, you're over here on this plane, so that means that your x is going to be equal to 0. So that means that it's going to be basically 0, y, z. And of course, for example, then you can say that you can say that any point on the, so this was the YZ plane, the XZ plane, this is X, and the XZ plane will have coordinates basically X, comma 0, comma Z, and any point on the XY plane will have coordinates X, comma Y, comma 0. So these are the things that we need to pay attention to here to basically have no, in order not to have any problems in the rest of the chapter, really, because the rest of the chapter is going to be based on these, some exercises based on these facts, and so on and so forth. So you don't want to miss any of these, really. And then the sign of the coordinates of a point determine the octant in which the point lies, of course. So depending on which octant you are in, depending on which octant you're in, your X, Y, and Z are either going to be positive or negative. So for example, in the first octant, you can see that your X is positive, your Y is positive, Z is positive. If you go to the second octant, your Y is still positive, your Z is still positive, and your X is going to be negative. Go to the third octant over here. Again, your X is negative, your Y is negative, your Z is positive. Come to the third octant. Over here, your Z is positive, your Y is negative, your X is positive. To the fourth octant, your Y is positive. 1, 2, 3, and 1, 2, 3, and 4. So over here, I guess I missed something over here. So this is basically the fourth octant. Whatever I said wrong over here, I apologize for that. But the fourth octant over here, your X is positive, your Z is positive, your Y is negative. And then you get to the fifth octant, which is right below the first octant. This is the first octant. So the fifth octant would be basically this octant over here, this one, right in the front. Down here, right in the front. So over here you can see that, in all of these octants down here, your Z is negative. If you get to the left of the XZ plane, of course your Y is going to be negative, and to the right of the XZ plane, your Y is going to be positive. And then behind the YZ plane, your X is negative. In front of the YZ plane, your X is going to be positive. So that's basically how these things change. And so based on that, you can of course make yourself a table if that's necessary for you. And that's basically that. So now we have basically two examples over here. Let's go ahead and solve these two examples, and then we have some exercises here. So in figure 12.3, so let me see what 12.3 is. Okay, so in this figure over here, if P is 2, 4, 2, 4, 5, find the coordinates of F. Okay, so we have basically this question over here, which is actually a good question. So suppose suppose that you have this coordinate system, 3D coordinate system here. Let's assume that the coordinates of the point P are 2, 4, 5. 2, 4, 5. Now what are the coordinates of the point F? So the coordinates of the point F, as you can see, you have the, basically, if you compare the height of these 2 points, you will have the same z over here. So then the z coordinate of this point is going to be the same thing, 5. Of course, the y coordinate of the point is going to be 0 because the point is on the xz plane, and the height of the point is the height of the point P. So not the height, but the x coordinate of the point is the same as the x coordinate of the point P. So my x coordinate over here is 2. So it's 2, 0, 5. Or another question, let's say that you have find the octant in which these 2 points lie. So you have -3, 1, 2, and then you have -3, 1, -2. So this point over here, as you can see, your x coordinate is negative. So if your x coordinate is negative, that means that you're either in the, basically you're in the back of the, so you have the y-axis over here and the z-axis. You're in the back of the yz axis. So since the x coordinate is negative, you are at the back of the, or the point is at the back of the YZ plane. And all of these, basically all of these x, z, y, z, z, x, and so on, and that I'm talking about, in all of these cases, I'm assuming that basically this is the y-axis, this is the z-axis, because this is z prime, this is y prime, and this is the x-axis. And this is the x prime x. Okay? Because in different books, what you will find is that people use different sorts of conventions, meaning that some people call this the y-axis, some people call this the x-axis, and some people call this, for example, the y-axis, and then some people call this the z-axis, which is of course acceptable if you basically define your coordinate system in that way. Of course, then you can use it in that way as well. There is nothing wrong with that. But then jumping from this system to another system, basically you will get confused. So you need to work with one single system. That's basically why. That's basically why I'm saying that in all of, at least in this chapter that we are talking about three-dimensional space, whenever I say that the YZ plane, for example, what I mean is that, for example, the plane that basically shares these two axes, this axis and this axis over here. and that would be basically this axis, this purple axis over here. That is basically the YZ axis that we are referring to. So you need to be careful about the way that I talk about these things. And moreover, that's actually in one way, that's actually the beauty of mathematics, that it is possible, that it is actually possible that it is possible for you to define things in a certain way, and then there will be no confusion or ambiguity between people when you talk about those things using those terms. For example, we have defined, for example, our coordinate system as, for example, having this axis as the y-axis, this axis as the z-axis, and so on and so forth. And then when I say the y-z axis, you will understand exactly what I mean by those, for example, by that phrase, for example. And the other basically astounding thing and interesting thing about mathematics is that it actually works in many mysterious ways in all the sciences, and all of these sciences are actually ways of dealing with nature. So that means that basically this everything that we are doing here, that we call it mathematics, is actually, all of this actually does work in nature, which is actually pretty amazing, really. So it's just like magic, only not only better than magic, really. So anyway, so now basically about this point, we were talking about this point. Now it basically, since the x coordinate was negative, so I concluded that I was at the back of the YZ plane, which is basically this, which is basically, as you can see over here, your x's are negative. And then over here, both, basically your y is positive. So if your y is positive, you have to be over here. You have to be over here. So now since the y coordinate is positive, you have to be the point has to be to the right of the XZ plane, and since your z is positive, and since your z coordinate is positive, then the point has to be to the top of the point has to be to the top of the XY plane. So what that means is that so therefore I can conclude that the point is in the basically x prime OY Z octant, or you can say basically the second octant, or in the second octant, or in the second octant. That is basically, for example, how you would analyze this logically. There is one more point over here. We will analyze this as well, and then we will end this video here after that. Okay, so now about the other point, -3, 1, -2. -3, 1, -2. So now this point is basically, this is your x coordinate, this is your y coordinate, and this is your z coordinate. Now your x coordinate is negative. Your x coordinate is negative. What that means is that the point is, it has to be behind the, so if you have your, basically, if this is the z-axis, and if this is the y-axis, and if this is the x-axis, then if your x is negative, that means that you're behind the yz, behind the yz plane. Behind the yz plane. Then if since your y is positive, that means that you're to the right of, behind the yz plane, to the right of the xz plane, so behind the yz plane, to the right of the xz plane, and basically since your z is negative, then that means that you are to the top of the xy plane. To the top of the xy plane. So you're to the top of the xy plane, behind the yz plane, and to the right of the xz plane. So that means that you are up here, basically. You are basically up here. That means that you will end up up here in this octant, which is basically the second octant. The sixth octant. So let me see. So your x is negative. Since your x is negative, you are to the back of the, or behind the yz plane. Behind the yz plane, and since your y is positive, you're to the right of the xz plane, and since your z is negative, you are to, I'm sorry, I made a mistake over here, to the bottom of, or you can say basically, to the, or below the xy plane. So now you are behind the yz plane, and to the right of the xz plane, and below the xy plane. And so what that means, that you are in the, basically 1, 2, 3, 4, 5, and in the sixth octant, basically. the sixth octant is right over here. So this is the first octant. This is the first, second, third, fourth. Over here, down here, you have the fifth over here, and behind that, right here, you have the sixth octant. That's basically where this point is, in the sixth octant. In the sixth octant. Okay, so basically I'm going to end this video here. After this we have a couple of exercises, and then we will get to the rest of the things. So I'll see you in the next video. Thank you.